tomorrow, Monday until Friday, I have another workshop from 9 to 5, But I need to give you assignment for preparation for test 1. Hopefully by sometime next week, I will announce you the date for test 1. Okay. So I'm thinking about doing it on Saturday afternoon. Okay, because I have another class, right? Section 1 and section 2. I think you are in the section 01, because I will do it simultaneously for test 1. For our test 1, covering the topic of single factor for completely randomized design, single factor for randomized block design, two factor multiple level, remember factor A, factor B, and also two factor two levels. Okay, so basically there are 4 major topics for our test 1, right? For our test 1. Today, we will continue discussing on the last example, right? And I think I will use a textbook to demonstrate this. Okay, for our, let me, okay, screen 1, right? Share. Okay, maybe I need to find our textbook for this. I forgot to open the textbook, So referring for our textbook, example from the hopefully, okay, textbook chapter right, chapter 13. Is it 13 or 14? I don't remember. On 2 by 3 factorial design. Look at example. I think last week I discussed using the slide, right? Using the slide. But this lecture I will discuss from the textbook. So that means please read the textbook. Okay, chapter 13. Chapter 13. The examples. Okay, the example on 2 of 3, right? 2 level, 3 factor. 2 level, 3 factors. Okay. I think we should follow the lecture. And also, as I mentioned, you can easily find the notes in YouTube. The notes on any topic that we have covered, right? YouTube or any Google or any PowerPoint slide in the internet. Same concept, same theory, Same concept, same. Okay, right? This is a 2 power of 3. Okay. Okay, I think this is example, right? This example is example 2 power of 3. Remember, you have 3 factors, A, B, and C. What is the A? A is feed rate, B depth of cut, C is tool angle, and 2 power of 3 is 8 runs. 1, 2, 8 runs. Oh, okay, 8 runs. And then 2 replicates. The response is surface finish, right? Replicate 1 and replicate 2, right? Replicate 1 and replicate 2. Okay, you need to analyze using ANOVA. I think I want to demonstrate how to construct the interaction plot, the interaction plot of AB. I think the last time we did construct main effects plot, right? Main effects plot. Okay. So as usual, I will give the using the pencil tool. So need to calculate the X bar, the average, remember? Okay. Average. I think previous example, remember previous example, right? This one should be 8, 8, right? 8, okay, and then 11. I think refer to the your 11, refer to previous notes. This one should be 10. Okay, 10. Okay, 13.5, right? 13.5, 13.5. And then 10.5. I think refer to your notes, guys. This is just a kind of revisions. 10.5. And then this is 23. Number 6. Okay, should be 11.5. This one. 11.5. 11, 0.5. 11.5, right? 11.5. Okay, this is 9. 9 and 15. And 15, okay? So we need to construct the AB intersection plot, construct AB interaction plot. AB interaction plot, plot. Okay. In order to construct AB interaction plot graphically, you need to do this. You need to do this. Okay, you need to do this. Do like this. Okay. You have A, factor A here. Low level, high level, factor B. Okay, B. Similarly, you do like this. Low level, high level. This is for AB. If you want to AC, just A and C. If you want to BC, B and C. Okay. For our graphical analysis, you can construct many factors of A, many factors of B, and many factors of C, and also two interaction. For A, B, C, you not be able to show graphically. Okay. If I ask you to construct A, B interaction plot, you just focus on this. Just focus on A, B, A, B column. So I don't know, for whatever reason, right? Just focus on A, B column. A, B column. That means A, B column. Okay. Then use the mean to construct A, B plot using the mean. This is the mean. Look at the mean. For example, look at A minus B minus, A minus B minus, get the mean, and also you have two here, A minus B minus, A minus B minus. So in this particular case, you take the mean of 8, 8, right? 8, 8 plus 8 plus 10.5. Is it 10.5? Yeah, correct. 8 plus 10, 10.5, 10.5. So 8 plus 10.5, so we'll get 9.25, the 9 here, 9.25. Similarly, you look at A minus B plus here. Sorry. A minus B plus. A minus B plus is 10, right? 10. So you put 10, 10 plus, look at another A minus B plus 9, right? 10 plus 9, 19 divided by 2, right? Divided by 2. So here you will get 9.5. 9.5. Okay. And then look at A plus B minus. A plus B minus. Okay. 11. 11 plus, look at A plus B minus, A plus B minus here, 11.5 here, right? 11.5, right? 11.5. So if you take average of these two values, you will get 11.25. You will get 11.25. Okay. So finally, look at A plus B plus. You know, A plus here, A plus B plus. You know, A plus B plus, which is 13.5, right? 13.5, 13.5, plus 13.5, 13.5 plus 15, the last one, plus 15. Okay, so you take the average here, you will get 14.25. 14.25. I think you can follow. Okay, from this value, you can plot. From this value, 14.25, you know, 14.25, this one, 9.5, 9.5, and then this one, 11.25, this one, this one, 11.25, and this one is 9.25, here, this value, 9.25, okay, you can plot here, you plot like this, you plot here, right, this is A, you have A low and A high, right? A low, this one is high. Okay, this one is mean, right? Mean. Okay, look, the value is 9.25 here. The smallest value, 9.25, right? 9.25, and then you have a 9.5, 9.5, and then you have 11.25, 11.25, and then finally the highest one should be 14.25. 14.25, 14.25. This value, okay. And then you plot B minus 9.25, right? 9.25 here. B minus 9.25, and then 11.25, right? 11.25 here. 11.25. So you correct the points. Correct this point. Okay. Sorry guys, I don't know why, because this is okay. This is B minus. B minus, you know, B minus. And then we have B plus here, 9.5, which is here, 9.5. And then this is 14.25, which is here. So this is, yeah, this is B plus. Here line is, this is B plus. Okay, this is B plus. If you look at this, this is called AB interaction plot. This is called AB interaction plot. Graphically, should be no interaction to A and B. Okay? The effects, effects using graph, effects of AB, is equal to the formula, right? One half, okay, open bracket, okay, effect of AB, that means effect of A at high B, which is here, effect of A at high B, 14.25, 14.25 minus 9.5, effect of A at high B, look at high B, 9.5, 9.5, so you make the bracket here, right, bracket here, minus effect of A at low B, 11.25, I think here, right, 11, sorry, 0.25, right? Minus 9.25. 9.25 minus 9.25. So minus that, you solve this, you will get 1.1.375. Okay, that means effect of AB is equal to 1.35, 1.375. The graphical is like this. Okay, the graphical show that there's no interaction between A and B. Okay, so similarly, you can construct, A and C and B and C, the two-way interaction plot, right? A and B, no, this I just construct A and B. You can do similarly for A and C. Look at column A, column C, and finally you can also look at here. You can also construct B and C. Just focus on B and C. This is for B and C interaction plot, B and C interaction plot. So look how the graph look like. So this is graphical analysis and how to calculate the effects of AB, from AB. Okay. Based on this analysis, we need to ask ANOVA, right? ANOVA, I think given from this one, after you do ANOVA, okay, this is graphical analysis. Remember, okay, hold a minute, Pencil. Remember that I just calculated here? AB. Okay. You can use a formula of graphical analysis, effect estimates. Effect of AB. What I just demonstrate is using graphical analysis, right? You can use also formula like this. This is effect of A. You can use also calculate effect of AB using the contrast, similar like this. This is effect of A. This is effect of A. You can use formula for effect of. Use formula can also to verify. Using formula. Effect of AB, right? AB using formula, you will get similar like this. Okay, the one that I just demonstrate using graphical. So guys, please take note. So for test 2 or the final, see if I can say using graphical analysis, the one that I just show in your previous note. If using the formula, you can use formula like this, using the contrast, right? Remember using the contrast, what effects? The formula here, calculate the effects. I think effects, right? Effects, right? Using formula, effects is equal to, remember, contrast, right? Contrast, C-O-N-T, right? Effect is equal to contrast divided by n number of replicates, right? It is 2 is 2 level, k number factor minus 1, right? So if you want to calculate effect of AB, contrast AB divided by n 2k minus 1, you will get similar like 1.375. Okay, so you can verify it in your own sweet time. Okay, for effect of B and C, you can use similar like this. Just contrast of B, contrast of C. For graphical analysis, you cannot use graphical for ABC. For ABC, you use a formula, right? That means for effect of ABC, so equal to effect contrast of ABC divided by n2k minus 1, right? N2k minus 1. Okay. You can use to get ANOVA, right? ANOVA, you need to calculate as sum square of A, sum square of B, and the rest, right? Using ANOVA. Okay. Look at ANOVA. Okay, this is the ANOVA, guys. Please take note. This is the ANOVA, right? For our example, ANOVA. Okay, we have factor A, B, and C. Many fact, right? We have two interaction, AB, AC, BC. We have three with the ABC, error, and total. Okay. Remember, for uh, for analysis, right? For analysis, assuming alpha equal, okay, alpha equal 0 0.1, 0.1. Okay, let's say alpha 0.1, right? Alpha 0.1. That means 90%. That means 90% confidence level. Confidence level alpha 0.1. Okay. If estimate alpha 0.01, this is significant. This is as significant because this 0.00, right? Negative 0. That means less than 0.1. Okay. 0.07 less than 0.1. That means significant, and the rest is not significant. And S not significant. The rest not significant. And S all not significant. Okay, that means assuming alpha, that means the effect, the significant are factor A and factor B only. Here, main effect of A and main effect of B only significance. Okay, A and B. The rest not significant because of P value, or you can use here. You can use here also based on F table. You know F. Look at table F 0.1. Look at 1.8. 1.8 degree of freedom. Okay, degree of freedom. If you look at this, all this value must be greater than F.118 from the table. All greater. That means when it's greater, that means factor A and B are significant, affecting the response. What is the response? Surface finish. Okay, surface finish. Okay, the rest are not. Okay. From this, we need to develop regression model. Okay, that's why today, in fact, I call you today is to understand the concept of regression model. Okay, regression model, right? Develop. This is regression model. Regression model. Regression model is equal to overall mean. You know, overall mean. Okay, overall mean. Overall mean. Overall mean. Overall mean plus significant factors. Significant factors. You know, significant factors. In fact, for our example, the significant factors is only A and B. You know, they mean A and B only. Okay, significant factors. Okay, I think given in the example here, but the most important thing is draw the main effect plot, significant one. Draw the okay. In this particular example, remember the one that I will just here, right? Remember AB. AB is not significant. That's why the graph is AB, right? AB not significant. That's why you show almost parallel AB plot, like AB plot like this. AB plot, right? You just construct line almost parallel. That means correct. That means AB not significant based on the parallel between A and B. Okay, A and B. Okay, A and B. Okay. Okay, this is from Minitab, right? Remember, I think last lecture, right? Arnab Samzuha from Bangladesh asking me why you all Minitab. Yeah, Minitab is a very powerful software for analyzing our statistical data analysis for our class. That's why all these results from Minitab, right? Since you live in Bangladesh, so I don't know how you get the Minitab, but if you want to get from online, you only get 30-day trial. 30-day trial. That means if you download today, that means this 30 days from now will expired and you cannot use. So I'm suggesting that you have to find asking your friend or somebody, to get the Minitab for the whole entire semester, semester 1, which is until I think February. So cannot survive, right? Until February 22. In fact, if your project FYP, right, using Minitab FYP, or if you project FYP, so until at least take 1 year. So definitely you need this software for data analysis. All these are output from Minitab. Yeah, from Minitab. That's why I mentioned many times about Minitab. This is output, similar, using P and okay. From this Minitab, you must be able to analyze. Remember Minitab, when I said overall mean, oh, sorry guys. This is overall mean, overall mean, overall mean, no? Overall mean. When I said overall mean, you need to add all, I think 16 observation, right? So you have 8 runs. You have 8 runs. Multiply by 2 replicates.
Increase sales revenue.
You have 16 raw data, right? You add all 0 raw data by 16, you will get this value. So you can confirm, guy. I think better you check your own, to confirm whatever I mentioned this in theory. In theory, I just verify only, but you need to verify. You add all 16 data divided by 16, you must get 11.0625. The effects, I think I calculate the effect of A. Remember last time I'm having difficulty here. Effect of A, and today I just construct here. Effect of AB, whether using graphical or using formula. So you must be able to verify, effect of B, C, and the rest. Okay. Okay. To get the regression model, remember the regression model? Regression model, regression model, right? Regression, right? Regression model, right? Model is equal to overall mean, which is 11.00625 overall mean plus coefficient of A, which is this one. Coefficient of A. Why A? Because A and B significant, right? A and B significance. Okay. That means 11 overall mean plus coefficient. That means 1.68 A significant, only significant, okay. plus B 0, look at the positive sign, 0.8125. 8125B. Okay, so this is the regression model for this data, 11.065 plus coefficient of A 1.875, okay, and also coefficient of B. Because why? Because A and B is only significant. You don't include other factors because not significant. It will distort your model. Okay, this is your model, the correct model. That's why I call you today, to listen to this lecture. Otherwise, if there is a problem, right? Okay, please read it, guys, on this example. What does it mean? Remember here, regression model. This is a general regression model. Okay. Okay. I think in this example, and this example, right? In this example, I don't know for whatever reason you don't include this, You don't include this, because only here, remember, 11.67 overall mean, right? Okay, this one is correct. This guy, this one is A, This one is X1 is A, this one is A, that is A, and the result is B. Okay, you only don't include this one, because it's not significant. Don't include X1, X2. Only include the significant factors only. Okay, significant factors only. Only. Okay, and this is very important. Again, why regression model? The regression model can be used to predict the surface finish at any point in the original experiment region. That means based on our setting. For example, consider a point where all three variables at low level. That means A1. So you can put this is overall mean, right? Factor A at low level, factor B at low level. In fact, you ignore this one, ignore, okay, because these are not significant. So you can put the value and then you can verify, verify. So theoretically, okay, verify full minute, that means you can verify, okay, that means verify, that means if you put factor A, right, A at low level, verify, here, factor A at low level, factor B, right, B at low level, you put the value here, so you will get verified, so you will get, okay, whole minute, y hat, predicted value is equal to, verify equal to 11.0625, right, 5. This one minus, right, minus, since A low level, minus 1.6875, and then minus 0.8125, 8125. So you can predict, right? You can predict if factor A at low level, factor B at low level, C doesn't matter because C is not significant affecting the response. So you will get, okay, in theory, 11.0625 in theory minus 1.6875 minus minus 0.8125, 8.56, 8.56, 6, 2, 5. So you can predict if factor A at low level, factor B at low level, so you will get surface roughness of 8.5625 microns, I think 8.5625 microns. If this value is within 10%, you know, between theoretical and actual, right? Theoretical and actual, because this is theory, 8.5625. So you run experiment, you will get around this. That means your result is confirmed, and the result is confirmed, right? That is confirmed. Result is confirmed. Okay. I think. Okay. I think you read. You read until all this. But don't include the x1, x2 because not significant. You know, not significant. Yeah. Okay. Similarly, this is for 2x3, right? Similarly, for regression model, I think from last example, I forgot to inform you about this regression model as well. For 2x2, right? Remember 2x2? 2x2, is it? Because I saw it regression 2x2. They have also developed regression model, So I think for the test one, right? You read the slides, you attend the lecture, my lecture, and read the textbook here, right? Read the textbook. I think I saw it. Regression. Okay, 2x2. This 2x2, 2 level 2 factor, right? Okay, 2x2. Okay, let review. Right? This is 2x2, right? Example. Similarly for effects, right? Effect of A. This one. Let me use the highlighter so that you all can follow my lecture, right? This is 2x2. This 2x2 experiment, right? 2x2. 2x2, you know. Two factor A and B and two level, low and high, 4 runs, right? And then you have multiply by how many replicates? 1, 2, 3, 4, you know. So multiply by 4. So total of 16 raw data, no? 16 raw data. So in order to construct ANOVA, please practice, guys. You need to square all 16 observation, you know, okay, to get the ANOVA, right? ANOVA. Okay, this is how you get the effects of A, you know, effect of A using formula, right? Using the formula. You can do also using graphical analysis, you know, effect of B using the formula, effect of AB using the formula. You can do also like this, you know, remember, to using graphical analysis. Using graphical analysis, you must do like this, you know, like this, right? You have A. Remember that I just, you know, A, low level and high level, okay? B, right? B, low level and high level. Look at this column, you know, AB, right? AB, okay? And then you need to calculate the X bar, the mean. X bar, you know. How to get X bar? You know, 64.4 divided by 4, so the mean. The mean, right? Mean, okay? Let me 64.4 divided by 4, right? 4, yeah, 4. 60.1 here, no? 16, 16, 16.1, 96.1, 96.1 divided by 4, 24.0, you know, 24.0, and the rest. So you can get the mean here, okay? And then A and B just follow. This is AB. This AB. AB, yes, okay, put here at this column, okay, and then you can plot AB. I don't know how the graph look like AB. Okay, this is okay. For A, I think simple, right? A, I don't know the graph, maybe like this for A. For B, maybe like this, the graphical analysis, graphical analysis. For AB, I don't, it depends whether the graph is, is there any interaction or something like that. But in this textbook they are using the formula, but I just demonstrate to you another method of using graphical analysis, but based on mean, guys, based on mean. That means for graphical, always based on mean, not based on sum, because I think I've seen so many students for test one, the previous semesters, they construct this graphical using the sum, using this. No, you don't use graphical analysis using sum. It's wrong. You should focus based on the mean, using the mean for constructing graphical analysis, using sum for using formula, sum for using the formula, using the formula. Please take note. It's a very, that's why if you don't attend my class, sometimes you feel confusing. Using formula, sum. For graph, using mean. Using mean. Okay. Okay. Based on this, right? Yeah. Based on this, always consult ANOVA. ANOVA, right? This one using ANOVA. Okay. This ANOVA, right? ANOVA. This is main effect of A, main effect of B, right? Main effect of A, B, and then this interaction AB. If you look at this, what is the effects? All significant, all significant, all significant, significant. Oh, sorry. So in order to develop regression model, remember regression model? Regression model? Regression model, that means regression model, yeah, is equal to overall mean, overall mean, overall mean, in general expression, right? Overall mean plus significant factors, plus significant factors, right? Significant factors. So in this particular example, all are significant. That means overall mean. That means the constant, right? The constant, the constant overall mean, the constant, right? Overall mean plus what? Coefficient of A, coefficient CO. Remember coefficient of A, because significant, right? Plus coefficient of B, coefficient of B, plus coefficient of AB, coefficient of AB, of AB. That means for this example, for 2 by 2, right? 2 by 2, regression model is constant plus coefficient of A plus coefficient of B plus coefficient of AB, because all are significant. All are significant. You look at this, very big. Or here, almost zero. It's almost zero. 10 to minus 8 to minus 5, all zero. That means significant at any alpha. That means factor A, factor B, and AB interaction are all significant, affecting the vibration, response, vibrations. Okay. If you look at example, right? Look at example. Okay, look at example. See there. This overall mean. Get it? This is overall mean. No, this is overall mean. Overall mean. So mean. That means you have 16 here, right? And then this is coefficient of A. Here is A. No, coefficient equal to effect by 2. A. This is B. This is AB. Okay. AB. That means because all significant, regression coefficient is effect, AB, right? Okay. AB. This is how they develop the example of predicted equation, predicted equation. Okay, this is overall mean. This is effect by 2 or the coefficient. What coefficient is coefficient of A? Yeah. 16 whole minute. Coefficient 16.64 divided by 2, right? 8.32. This one is 8.32. Coefficient, 8.32 A, right? A. This one 7.54 divided by 2. 7377. 3.77. 3.77 B. This one coefficient, right? Coefficient effect by 2. 8.71 by 2. 4.355. 4.355 AB. AB. Coefficients, coefficients. Okay. If you look at the ANOVA, right? 8.32A plus 3.77B plus 4.355 AB, the coefficients effect by 2. I don't know whether they have ANOVA or not, for this example. No, the Minitab. No Minitab, No Minitab. Okay, remember here, this is a very interesting, right? This graph of, since you understand, right? The AB is significant. AB is significant. So you look at the graph. AB significant. Look at the graph. It's like this, right? It's non-parallel. So how to construct the graph? Using the mean. Using the mean. Okay. Using the mean graph. Okay. 1 minute, They are using the mean or the actual the sum. It looks like using the sum. Right? Using, I think they are using the sum. You should use the mean, using the mean. Using the mean here. I think the graph is using the mean. 1 minute, Here. You should use the mean, guys. Using the mean. This one. Using the mean, not using the graph, Using mean. Using the mean. Okay. Using the mean, do like this. Right? You have A, right? Negative plus use, negative plus, and then look at the, the column here, A low, B low, A low, B high here, right? A, A plus, B, and then, so you can plot this graph. This is called AB. AB interaction plot, no, A-B interaction plot is called A-B. Okay, that's why today, and then you look at example here, you know, the A-B interaction plot, you know, look at this interpretation, right? Look at this interpretation. Okay. Yeah, I forgot to explain this 2 by 2, right? This is example of A-B intersection plot. Significant, significant because it's non-parallel. And using the mean and not using the sum. I think they are using the sum, you know, it seems to be very big. Should be using the mean. Yeah. I think they are using the sum, I think. It's using the sum. But you should use the mean, using the mean. 44, 13. You can check again. Check the use the mean, use the mean. Let me try to calculate here. Oh, sorry. X bar, right? X bar. This one, okay, 64.4, 64.4, but by 4, right? 16.1, this one should be 16.1, this one, 96.1, but by 4, 24.0, 24, okay, 24.0, 59.7, 59.7, 4, 14.9, 14.9, 14.9, and finally 161.1 divided by 4, 40.3, 40.3. So you use this value, right? This value to construct like this. To construct A low, B low and high. Okay, A low, B low, 16.1, 16.1. A low, B high. A low, B high, which is 14 point, I don't know, 14 point, maybe 14, 14.0, I remember. And A plus, okay, 24, 24. And finally, A high, B high, you know, this is high. This is high. 40 point something. 40 point something. Okay, you plot like this, you will get the plot that I just show you, you know, like this. You plot like this. Something like that. Something like this. You know, the one that you show based on this. Okay, A, B, okay. Yeah, I think this is the one from the notes, right? They don't show you how, but this is the one that I show you how to construct the A-B intersection plot. A-B intersection plot. There's a plot here. Yeah, here. I think correct. They're using the mean, here. Using mean. Using mean. Not sum, Not sum. Not sum. So this guy, for test, remember here, using mean. Okay, guys, I think any questions? We have 5 more minutes before 2. Any? Stop sharing. Any question, guys, regarding the today's topic? How to construct the two-way interaction plot, and also how to develop regression model based on significant factors, and then how to develop a predicted model given the certain level. Whether you run at low level, you just plug in the value plus minus into the theory regression equations. Okay, any questions regarding the today lecture? Any questions? No. Okay, if there's no question, thank you very much. I think I will give some assignment for practice within since you have no class for this week, right? So I'll give you some assignment so you can prepare, and then I will try to get the date. But basically, I will try to get the test one on Saturday, not next week Saturday, maybe 2 weeks from today, right? For our test one. So covering, as I mentioned, 2 by 2. 2 by 2, the one that I just show you, right? 2 by 2, not 2 by 3, right? 2 level, 2 factor, that kind of thing. Okay. Thank you guys for attending this today lecture. A good time, right? Lunch hour, but I have to call you because of we might miss, certain topics. That's why just to get the ideas, because we don't have enough time last week, to demonstrate the theory of constructing two interaction plot and also developing the regression model. Okay, guys. Thank you very much for attending this class, and make sure you write your name at this chat section for attendance purposes. Thank you.
Doktor. Okay, doktor.
Okay, terima kasih.